In this video, we are looking at the refraction of light. Refraction is a property of all waves. If you look at this diagram, we have an incident ray coming from the top left, entering the glass from air. And when waves cross a boundary between two mediums, they change speed. If this happens at a non-zero angle, they will change direction. In this example, a light ray is passing from air to glass. Notice, as with reflection, we again draw a normal at 90 degrees to the boundary, shown by the dotted line. In the diagram, I is the angle of incidence. This is the angle between the normal and the incident ray. R is the angle of refraction. This is the angle between the normal and the refracted ray. Notice how, when passing from air to glass, the light moves towards the normal. This is because light travels more slowly in glass than it does in air. This is because glass is more optically dense than air. In other words, the angle of refraction is smaller than the angle of incidence. The opposite also applies. When travelling to a less optically dense medium, the light is refracted away from the normal. The angle of refraction is then greater than the angle of incidence. It is also important for you to know that light can be partially reflected at the boundary, as well as being transmitted through it and refracted. Alright, time for the old-fashioned quiz. What happens to a wave when it goes from a less optically dense medium to a more optically dense medium? 2. When a wave goes from a less optically dense medium to a more optically dense medium, which is bigger, the angle of refraction or the angle of incidence? And finally, if you are aiming for a grade 8 or 9, you need to be able to plan an investigation that will allow you to measure the angles of incidence and refraction. This is a required practical. Also, can you explain how a triangular glass prism splits white light into its different colours? If not, find out why.